Hello everyone. Today we are going to talk about SPT N-value. Okay, still on chapter number 2, and the point number 4, physical sampling and penetration test. The physical sampling, I think in the previous video we have talked about sampling methods, different sampling methods. Okay, including the SPT spume sampler. Okay, in this video, we are going to talk about how to obtain soil parameter from SPT N-value. Okay, all soil parameter, including the internal frictional angle, unit weight, the relative density, okay, the Young modulus, everything. How can we obtain those from SPT data? Okay, this is what we are trying to cover in this video. So before going to that, we are going to just come back on what is SPT and what is SPT N-value. I believe that in the previous video, we have talked about this, okay? So it was said that after doing the borehole like this one, for example, we load the SPT sampler like this sampler at the bottom of the borehole, and then we start driving this sampler into the soil using the hammer, okay, by hammer blows. And you can see the characteristic of the hammer and the height of dropping the hammer. We talked about this last time in the previous video. Please go back and check. And we have to count number of blows required for the penetration of 3 times 15 centimeters. Okay, as you can see here, 15, 15, 15. Okay, actually it is like this in millimeter, but it's difficult to measure this millimeter, 2 millimeters. So we say just 15 centimeters. So 3 times 15 centimeters. So how many times you dropped the hammer to reach this depth to obtain 3 times 15 centimeters? And the N number, the SPT number, standard penetration number N, is just the number of blows required for the last 2 intervals. Okay, these last 2 intervals. You can see here N, number of blow, 0.3 meter, right? Number of blow 0.3 meter. If you convert this 0.3 meter, it is just the 30 centimeter, which is twice 15 centimeter. This means here, from here to here, the number of blow required for the last 2 intervals. Okay, so please remember what is N-value, the standard penetration N-value. And after that, we are going to see how we can obtain soil parameters, several soil parameters from this N-value. Okay, all right. So penetration, for the sampling, I said already, we have seen how the sampler works. Okay, so we are not talking about sampling here, it's just the penetration itself. So this N-value is actually there are some factors, several factors that contribute to the variation of this N-value. It means this SPT N-value is affected by several factors. Okay, and these factors include like the hammer efficiency, SPT hammer efficiency. We will see what is efficiency means. Okay. The borehole diameter also affect the SPT N-value. Okay, the sampling method and the road length. The road length will also, this is road length, will affect the CPT, the SPT N-value. Okay, so because of this, all these reasons, we have to bring some kind of correction. Okay, as for the SPT hammer energy efficiency, this one, the first one seated here. Okay, I hope you understand the meaning of this. It means for the same soil, same profile of soil, if these are not the same, so you will not get same N-value, despite you have same soil profile. Okay, the SPT energy efficiency is given by this formula. Okay, ER in percentage, the actual hammer energy to the sampler, and the input energy. Okay, the input energy, theoretical input energy is just this one, W by H. What is the meaning of this? It means the W is the weight of your hammer. Okay, H is the height from which the hammer is falling. Okay, weight multiplied by H, it is energy, potential energy of due to the pesanteur. Okay, so when you are dropping the hammer from a given height, it is this theoretical energy. However, it is not that entire, the whole energy is not transferred to the SPT sampler. There are some losses. You understand? So when you hit, you drop the hammer. So theoretical energy from this sampler, the SPT sampler, is not receiving that whole energy. There are some losses in the ground. Okay, that's why we need to investigate to know the efficiency. So the efficiency is the actual energy that the sampler is receiving, okay, divided by the input energy. It means the theoretical energy, weight multiplied by H, by height. Okay, so multiplying by 100 is just to make it in percentage. So this will affect the N-value. Okay, as you can see here, SPT hammer efficiency. Okay, so okay, W is just the weight of the hammer, H is the height of drop. So the theoretical input energy is about this 0.474. Okay, yeah. So in the field, the magnitude of the ER, remember this is ER, okay, in percentage. The efficiency is ER. So in the actual field, if you do the SPT test, this ER, the efficiency can vary from 30% to 90%. It depends on the ground, okay? So the standard practice in the USA, the standard practice is to express the N-value to the average energy ratio of 60%, okay? And we will call it now N60. That means the N-value where the efficiency is 60%. Please, I just gave you the definition of energy efficiency, the efficiency, okay? Okay. So the standard, in the standard practice, we want this. So the correcting for the field procedure and the on the basis of field observation. Okay. It then reasonable to standardize the field penetration number as function of input driving energy and its dissipation around the sampler into the ground. Okay, so the N60 then will be N, which is multiplied by these factors. Can you see these factors? Okay, we will see what is the meaning of this factor. And then you divide by 60. Okay, so no matter the N value you obtain, use this formula to obtain the N60. This is now the standard, the corrected N value. Okay, depending on the hammer, the type of hammer you use, you will see soon these factors, the correction from these factors. So N60 is the standard penetration number, the normalized one, standardized one. Okay, corrected for field condition. The N is the measured penetration number. This means the actual count, the blow count you obtain from the field. Okay, this N, this is raw one, if you can put it in that way. It's not corrected one. This is the raw one, it's not corrected. Okay. Then this one, this factor is the hammer efficiency, the hammer you are using, because there are different type of hammers. And this one, B, is correction for the borehole diameter, because in the parameter, in the different things that affect the N value, we have seen that the borehole diameter also is included. Okay, this one is the sampler correction. Okay, this sampler, as you can guess, there are also different type of samples, and also the road length is also affected. So we include R, this R to this coefficient to correct that also. Okay. So I think it's very easy. Just know what is the meaning of N. N is the count of the two last 15 centimeters. Okay. And eta, this eta, the coefficient eta H, eta B, eta S, eta R are the correction factor. So depending on the equipment you are using and the country where you are, these values are different. We will see now. So this is the standard penetration number, N60. Okay, so I will put this here, and the variation of these eta H, eta B, eta S, eta R, based on the recommendation by this reference and this one, are summarized in this table. Okay, so this one is about eta H. Do you remember eta H? What is it? It's here. Eta H is the hammer efficiency. B is borehole diameter, and sampler and road. So eta H is the hammer efficiency. In Japan, the hammer type, see the hammer type? In Japan, it is a donut type. Donut. So in United States, it is this one. This type, Argentina and China. Okay. So if you are in Japan and you have this, of course, in Japan, it will donut type. And the hammer release, how do you release the hammer? If it is free fall, then the hammer efficiency is 78%. Okay. If it is rope and a pulley, the pulley, you